Alright, moving along with trig, we want to talk today about the unit circle, which is just a circle with a radius of 1. And we know from our past study that the equation of a circle is x squared plus y squared equals radius squared. And that's easily shown because if you take any point on a circle, x comma y, and you have a radius r, you can construct a triangle like so, where this is the x distance, this is the y distance, and this is r. And by Pythagoras, we get this relationship between x, y, and r. And so that's the equation of a circle. In the case of a unit circle, we're talking about a radius of 1. So I can replace that with 1. And therefore, the equation of a unit circle is x squared plus y squared equals 1 squared, or just like so. Now, why would we want to talk about the unit circle, you ask? Well, you'll remember with trigonometry that we have defined our three primary trig ratios: cosine, sine of the angle, and tangent of the angle, in terms of our coordinates x, y, and the radius r. So cosine, remember, is the x coordinate divided by the radius, sine is the y coordinate divided by the radius, and tangent is the y divided by the x, which is like slope. Now the cool thing with a unit circle, a circle of radius 1, is that would mean that cosine, if the radius was 1, cosine is simply the x coordinate on the unit circle. And sine would be the y coordinate on the unit circle, and tangent would still be the slope y over x. So if I had an angle here, and I had a point given, I would know the cosine and sine of my angle simply by knowing the x and the y coordinate. So here's just a little animation to show you how this works. I've got my angle here in degrees, and I've got a circle with radius 1, as you can see, 1 unit. And as I move this, the coordinates of the point where the terminal arm hits the circle change. And I've also got shown, have been shown here, the sine, cosine, and tangent of the angle. Well, you'll notice that the x coordinate of the point is the cosine if the radius of the circle is 1. Cosine is x over 1. So the x coordinate on the unit circle is the value of cosine. The y value of the point of intersection on the unit circle is sine. And tangent is the y coordinate divided by the x coordinate. And of course this changes depending on what quadrant we're in. We've talked about this in the past a little bit. But the cool part of a unit circle is that when the radius is 1, our cos and our sine are simply our x and y values at our point of intersection. So let's just do a little bit of practice with the unit circle so we can do even more exciting things with it moving forward. I have a question here that says, find the coordinates of all points on the unit circle for which the x coordinate is negative 5/8. So let's just clear the picture here. If we had an x coordinate of negative 5/8, that would mean that x would be over here somewhere. Remember, this is negative 1 because we've got a unit circle we're dealing with here. So negative 5/8 would be approximately here, and where it intersects the unit circle would be here, or it could also be here. So there are two different angles I'm talking about. The x coordinate is negative 5/8. The y coordinate is unknown. Okay? And similarly here. Now I'm not being asked to calculate what the angle actually is, although I'm sure you could probably do that since we've talked about that in the past. Right now we just want to figure out what the y coordinate is, what the y value is. Well, since we know the equation of a circle, we can just plug in our value of negative 5/8 for x and solve for y. So 1 is 64/64, minus 24/64, which is 39/64. Square root both sides. and we get plus or minus the square root of 39 over the square root of 64, which is 8. And so to answer the question, our coordinates are negative 5/8, positive that, if my angle terminates in quadrant 2, or this if my angle terminates in quadrant 3. Okay, again, I'm not being asked to calculate the angle, but what we do know from this is that we know that the sine value of the angle, depending on which angle we're talking about, is the y-coordinate on the unit circle. This is the unit circle, so sine would have been this. And cosine is the x-coordinate on the unit circle, would have been negative 5/8. We can also determine specific coordinates on the unit circle from our special triangles. You'll remember this. One of the special triangles is a 30, 60, 90 degree triangle that has a ratio as shown here. And so the way I could apply that to the unit circle would be is if I were to move my 30 degree angle to be here, so my standard position angle is 30 degrees. Let's try to establish the x and the y coordinates on the unit circle. The only issue here is that this piece here corresponds to this, and we want a radius of 1. So what we're going to have to do is scale down this triangle so that it has a radius of 1, and we can do that simply by dividing all the sides by 2. And so that would make my x distance, which is my x coordinate, root 3 over 2, and my y coordinate 1/2. So if you were asked what is the cosine of 30 degrees, instead of using the triangle as we have in the past, you could directly use a unit circle, because if the radius is 1, the cosine will be the x coordinate and the sine will be the y coordinate. But the great thing about this is that if you wanted to take an angle whose reference angle was 30 degrees, so let's suppose I took an angle here. Now the standard position angle would look like that. And the standard position angle with a reference angle of 30 here, there's the reference angle, would make this angle here 330 degrees. So if I asked you what's the cosine of 330 degrees and the sine of 330 degrees, because you know the point where 30 degrees intersects the unit circle, you also actually then know the point where 330 intersects the unit circle, because this is simply a reflection across the x-axis, which means that the x-coordinate's the same and the y-coordinate's opposite. Okay, so the cosine is the x-coordinate, which is still root 3 over 2, and sine is the y-coordinate, which is negative 1/2. Okay, you can check that in your calculator. Type in sine of 330, you're going to see that it's negative 1/2. All right, so you can use this process with special triangles for any of the special triangles. Okay, I just did it with 30, 60, 90, but you can do it with 45, 45, 90. Maybe one other thing I'll mention is, what if you were asked simply what is the sine and cosine of 180 degrees? Alright, so let's go back to our unit circle, and I'm just going to erase everything off of here so we can see it a little bit better. 180 degrees in standard position would be an angle terminating right here. Okay, so what is cosine? Very simply, it's the x-coordinate on the unit circle. The unit circle, this point, what is this point? It's negative 1, 0. So cosine is negative 1, the x-coordinate, sine is 0, the y-coordinate. Type it in your calculator to verify it. Okay, so main point, cosine is the x-coordinate on the unit circle, sine is the y-coordinate on the unit circle.